Good morning, everybody. It's so nice seeing you guys once again. So, I heard you guys started Rust last week, right? Is it last week or last 2 weeks? So, please, are you guys hearing me? Like, hope I'm audible enough. Okay,
Yes,
okay.
sir, you're audible.
All right, all right. So, I heard you guys started Rust, and then um, I'm going to start from beginning, all right, to complement what the other mentor has taught you guys, because one thing with rust is not difficult, but at the same time it's something that you need to go over again and again and again to fully understand it. So that is the nature of rust, because unlike other programming languages, it has a massive shift in paradigm in the sense that the way you approach Rust is a little bit different. That's in the core areas of Rust. There are some things that are different from the normal conventional languages we are all used to, like JavaScript, Java, Python, and the rest. So that is how Rust is. That's why if you meet some people, they'll tell you Rust is hard. Not that it's necessarily hard, but it's because it has a massive shift in paradigm, how things are being done. So getting used to it is where the problem is. And that involves you going over it again and again and again. So that's why I'm starting from scratch again, so that at least the one you got from your mentor added the one you get from Miss Stephanie added with the one you get from me. By the time you combine those two, you have more understanding of what it is. All right. So I'll be sharing my screen now. So as usual, if there's anything you don't understand, please make sure you bring it to my attention. All right. So I don't know if my screen is visible. So is it visible?
Yes, sir,
All
I
right,
can see your screen.
all right, awesome. So today we'll be looking at introduction to Rust programming for beginners, and we'll start with Rust fundamentals for smart contract development. So everything we'll be learning today is what is going to prepare you for writing smart contract using Rust. Of course, before you even start writing smart contract, you need to understand the Rust, the fundamental of Rust. All right. So let's continue. Uh Cheers, this one. So welcome to Rust. Now I know somebody might be asking that why Rust? We have JavaScript, we have Java, we have Python, we have Solidity, we have Cairo. Why are you now stressing us again and say Rust, right? So Rust is a systems programming language, and it's not just a system programming language, but it's a system programming language that emphasizes on safety and performance. So one of the major selling points of Rust is memory safety. Now, like your other conventional programming languages, like your Python, your JavaScript, they have what they call garbage collection. So now, if you run a program, right? Let's say we have uh it's as if I'll need to reshare my screen so that you'll be seeing everything. So permit me to reshare my screen so that you get to see everything, because I need to do some illustration for you to really understand why why we are just hustling Rust up and down. So I don't know if the screen is visible. So uh so just like I said, if there's any question, you please let me know. So now, in programming, right? Like JavaScript now, if you want to do anything, You can say, okay, let's name, right, equal to, you can do something like this. Fitech, right? You say let number equal to, let's say, 707, this, right? Then you can now come here and say name. Wait, is this allowed at all in JavaScript? Right? Then here you can now come and say number, right? Number. Now, if you run this thing on your, oh, sorry, it's not necessary. Run this code on your computer. Let's say I'm running this code on your computer. Even as I'm running it here, what is actually happening is that these two variables, name and number, they are being stored inside my computer RAM. I believe we all know what RAM is. That's random access memory. So once you have a running process, for instance, I'm running this browser, my Brave browser. This Brave browser, once I'm not running the Brave browser, like the Brave browser is just on my system, I'm not using it. At that point in time, it's only stored on my storage. That's my hard drive. You understand? Just like how you store your music on your hard drive, you store video on your hard drive, you store documents, pictures. It's on your hard drive, it's on your storage. Now, once you run that program, that application, you start playing that video, what happens is that it now moves, like now that I'm running this browser, it moves the running process of the browser, it moves it to the RAM. So as I'm running this emulator on my browser, I'm running this JavaScript program, what is happening is that this name, this variable name, and this variable number now is being stored in my computer RAM, right? That's why you see that if my system off and it comes back on, you see that I will lose whatsoever thing I've stored here because it's being stored in RAM, and RAM is a temporary storage. Once your power goes off, your RAM too, everything stored in it too goes off. So it's being stored in the RAM. Now, how other languages like JavaScript and Python, how they handle this memory, storing of all these kind of variables and arrays, object, and the rest, how they handle it is that they make use of what they call garbage collector. Now, this garbage collector, what it does is that as you are using these variables, it will be watching, looking at what you are doing until it gets to a point where he feels like, okay, it's as if this guy is done using all these variables he has declared. He's done using it. So at that point, what is going to happen is that this garbage collector is now going to collect all these variables, clean it out of your RAM. Why? Why is he doing that? So that your RAM will have more space to be able to run other things. So that's the reason why some of you, I don't know, maybe some of you have experienced, maybe you are using a system that have very small RAM, low RAM, and then you are running a browser, you open 2, 3, 4 tabs, the browser is normal. You now open maybe 10 tabs, you now see that it's now becoming slow. You open another program, you see that it's becoming slow. It's because you are trying to run multiple processes inside the RAM, but the RAM is not big enough to contain it. So what other languages do is that they use this garbage collector. So it's more like they are trying to guess. This guy is as if he's done with what he's doing. So please, let's clean up this RAM storage for him so that in case he wants to run other things, he's going to have additional space for those other things. So these things are called garbage collector. All right. But Rust now, unlike these ones, Rust now makes use of what we call Rust makes use of what we call okay, we'll still come to that. Let me not jump. So this Rust, one of the key features is that it doesn't make use of garbage collection. All right. So which makes it to be memory safe and much more efficient. All right. So another thing is high performance. Rust is very, very fast. If you use JavaScript for something and use Rust for something and you compare the speed, majority of the time you find out that Rust is much more faster. Now, if you are writing a small program, right, you see that in your you might be like, does it even matter? Sorry, let me close this. So you might feel like, does it even matter? But imagine you are running a program that about a billion users. It has about a billion users. Or you are using a service that has 1 billion users or 1 million users. You understand? So all those kind of things. So it's also excellent in concurrency. We'll still look at this concurrency and all of that. So all of these features is what actually makes it ideal for developing secure smart contracts. Because the goal is not just to write smart contract, but it's to write smart contract that are secure, because what you are dealing with is actually money. Yeah. So that they will not go and look for a way to hack and all of that. So now, what is Rust? Just like what we have done in the previous this thing, right? Number one is a systems programming language developed by Mozilla. So it was actually Mozilla that developed Rust. It all started from Mozilla. So secondly, focuses on performance, reliability, and memory safety. I explain a bit of that, right? So we'll still look at what Rust makes use of. Others make use of garbage collector. So we still look at what Rust makes use of. So next, you see, no garbage collector, unlike Python, JavaScript, and Java. And then four is great fit for web assembly. In fact, this is even one of the reasons why smart contracts, another good reason why it's being used for smart contract development, because of web assembly. They call it WASM. The W means web, while the ASM means assembly. So this web assembly is a feature that makes Rust to run on the browser. Majority of the time, you find only JavaScript running on the browser, right? But Rust also can run on the browser, on your browser environment. So that makes it a very, very good, suitable candidate for blockchain. That's why blockchains like Sion are making use of it, like Soroban and the rest. So let's see. So why learn Rust, right? So one, just like we said before, Rust is used for building smart contracts. Two, it compiles to WebAssembly. That's, you can compile Rust to run on your web browser environment. Three, it guarantees memory safety and performance. Just like I said, is very high in performance. And then four, Rust is popular in the blockchain space. In fact, some people have this misconception that once you mention Rust, their mind immediately go to blockchain. But Rust is not really blockchain. It's just that Rust is being used for blockchain. Rust is not like Solidity. Solidity, once you mention Solidity, is Web3. And they don't use Solidity for Web2. But Rust is not like that. But then some people have that misconception because of how popular it is in the blockchain space. So Rust is not actually Web3. You can use Rust for anything. You can use Rust for Android development, mobile development, for web development, for embedded systems, for so many things, blockchain and the rest. So, and this Rust, that's what is used by Solana. I think Solana have a framework that is a Rust-based framework called Anchor. That's what they use in building their smart contract. Then you have Near. Then you have Polkadot. So this Polkadot is what can help you to build your own blockchain. You can use their product. Is also written in Rust. You can use it to build your own mini blockchain. Let's say you want to build your mini blockchain for maybe your business or your company. You can use Polkadot. Yeah. So, but I don't have much knowledge on it though. So now, before we go on, because we are about to go to although I'm very sure that majority of you must have installed the necessary tooling for Rust. That's your cargo majorly. Yeah, because your Rust C still runs beneath, like what cargo runs beneath the hood is actually this your Rust C. And as this your Rust top is just like what helps you to manage the installation, whether you want to upgrade your Rust version, you want to update it, you want to downgrade it and all of that. So Any question before we continue? We want to ask how many of you have set up your Rust environment? Like your Rust environment is okay, so that we don't need to do additional work. We just go straight to the point. Okay. Okay. Go on.
Hello, sir.
Yes, boss.
Yeah, honestly, Baxter, we really struggled with installation. I will not even lie, we struggled with installation. Some people have done it, but a lot of us have not, and some others haven't.
Okay. Okay. Wow. So Tali, Alpha,
So I wanted to ask, can Rust be used for reactivity like JavaScript?
for
Or just for reactivity like JavaScript?
uh activity like I don't understand. Sorry.
Reactiveness, like how JavaScript is very reactive. Since you said Rust is
Okay.
also
Okay.
made.
Okay.
Okay.
Okay. Okay. Okay. I understand. I think it is. Oh, I think so. You can check it out because there are Rust framework. That's front end frameworks for Rust, and people are using it to build products. Self. So yes,
Yes, now there are frameworks for
Okay,
us
sir.
now.
Thank
There
you.
is Action, there's whatever
you
like
are,
that.
you are welcome. So you can check them out. Even GUI, you can build GUI with Rust. That's a graphic user interface that can run on Windows, Linux, Mac, or any kind of operating system. Yeah. All right. So I'm pretty sure that majority of you must have set it up and install it because I'm looking at time, right? I'm looking at the time constraint. You see, we have about 20 slides, and we are just on slide 5. So let me just give a brief explanation, and then I will likely drop links where if you are using Windows, you get to use it to as a guide to install on your Windows. You're using Linux. If you're using Linux or Mac, I believe the installation should be very, very easy compared to Windows. At times, Windows wahala. Yeah. So Rostov is actually like a toolchain manager for Rust installation, right? So you can use it to install between versions of Rust, whether you want to upgrade your existing version or you want to downgrade something of that nature. Okay, let's even have a demo, right? Let me increase. I'm coming. So, so I don't know if it's big enough. So is it big enough? So you can see when I press the raw stop, you can see the ROS tool chain installer. So you can see default, set the default tool chain install list tool chain. So this tool chain now, and here let me even show you guys, right? So let me do tool chain, Rostop tool chain. Let's see something, right? Um, okay, Rostop tool chain list. Yeah. Okay. So if you look at it now, right, I have about 3 tool chain here, which is the stable one for my Mac, the nightly version. The nightly version is like the test, the beta version. You understand? So this stable version is the stable one. Why this nightly is like the test, like features they have implemented, they are still like testing it. They want to make sure it works the way it's supposed to work before pushing it to the stable. And then this risk, honestly, I've even forgotten what this risk is about. So, so these are the tool chains and all of that. And just like I said, you can use this raw stop to upgrade. I think if you use raw stop upgrade, is it upgrade or update? Let me confirm. Yeah, so it's actually upgrade. So if you use raw stop upgrade, it's going to check for the most recent version of Rust, both the stable and the nightly version. It will check it and then update it. So, and you can see it's installing some components like cargo, which is like your package manager in Rust, Clippy, Rust docs, I believe that some of you must have gone through the Rust book. You can access the Rust docs. You can actually access Rust docs directly on your system. Yeah, instead of going to the internet, you can access it from your local environment. So that's it. Rust standard, it contains the standard libraries. That's what contains the standard libraries of Rust. And then Rust C, which of course we all know that is the Rust compiler. Is the one that is running beneath the cargo. When you do cargo run, you're actually calling the compiler to compile your program and give you an executable, give you what you can run on your computer. Like take the code you have written, convert it to something you can run on your computer. So that's what is happening behind the scene. And then you see Rust FMT. So this Rust FMT is the Rust format. You can use it to format your code, your Rust code. Yeah, so that's it. So that's one of the use of your Rust up. All right. So there are many Rust up. You see all the commands which you can run using the Rust up. You can see update Rust toolchain and Rust up. So you can just go over it and then understand. So you can see it as for my, you see, for my stable is unchanged. I already have the most recent version in my stable edition, but my nightly edition of Rust, it's updated it. So that is pretty it. All right. So we have seen what Rust up is. And cargo, what cargo? Just like I say, cargo is like your npm. I believe most of us are familiar with npm. Npm install, npm init, and all of that. So cargo too is like npm, but in this case for Rust, just like how npm is for JavaScript or TypeScript, cargo here is for Rust. And then just like I said, the Rust C is your Rust compiler, is what is being used under the hood by cargo. Once you do cargo run, you see that it compiles and run your program. You do cargo build, it will compile your program to an executable that you can run. So all those things, beneath it is Rust C that's actually doing the compilation. Cargo is just the package manager that's managing everything, but Rust C is actually the one doing the work of the compilation work. Yeah. So any question before we start? Hmm? But hope you guys are good. Like you are following up, you are getting it. All right, all right. So no problem. So now let's look at setting up a Rust project, right? So to set up a Rust project, you just need to run the command cargo new and then the name of your project, right? Now, just like I said, you like it's not always necessary to use cargo, but it's always advisable. Just like how to set up a JavaScript or TypeScript project, you always go through either use npm or use pnpm or use yarn, right? So it's also always advisable to always make use of cargo. It's easier. There's no point of they give you soft, they give you hard. There's no point of still following hard. You understand? Somebody's raised. Okay, go on, Tally.
I don't know. Okay, there's one other day I joined the class late, so I was hearing I think Adebakin, he was talking about installing Android Studio to run Rust, or maybe something like that. I don't know. Is that
No,
needed?
no, it's not. It's not
Okay.
at all. All right, all right. So now let's do this, right? Let's do this, and then let's look at what is going to be created and all of that. So I'll open up my terminal, and then I'm going to open. Let me use. So which one should I use? Should I use VS Code or should I use Z? Which one would you people prefer?
VS Code, sir. Yeah.
Yes,
For
yes, good sir. Yes.
so no wahala, no wahala. VS Code carry the una carry vote.
Sir, may I have a question? Is it that that one is better than VS Code? Is it better for Rust in particular than VS Code?
Uh, Z, right, is a code editor that they use Rust in building the code editor. So, it's more like inbuilt of it is Rust. Like now, for this my VS Code, I believe many of you must have installed this plugin code LLDB and also this other one, Rust Analyzer. Hope you guys have installed these two.
No, no, sir, we have not. Oh.
So please do that.
Sir, we
Sir,
don't
let's
even know
try
ourselves.
if I
Wow.
start to talk.
So please, you guys should install this too. I was thinking you must have installed it. So your Rust Analyzer, just search your extension Rust Analyzer. So once you search, you see this one is deprecated. So don't bother about this. This one is in Chinese. Unless you want to be coding in Chinese. So this is the one you go for here. I think it has the most number of downloads. Let me see if it's going to show here. Okay, it's not actually showing. Okay, about 4 million, 4.7 million downloads. So that's the one you install. So you install this Rust Analyzer, then you install the other one, Code LLDB. So it's also very good. Code LLDB. All right. So now we are here now, right? Now what I want to do is I'll bring up my terminal here inside my VS Code so that we'll be seeing everything here. So just like we say, from what we have here, we say to create a new project, you use the command cargo new and then the name of the project. Now in this case, you are using Hello Rust. All right. So I'll come back to my VS Code and then I'm going to run cargo new. Remember the new keyword and then the name of your project, Hello Rust. Is it underscore? I think they used underscore. Although whether you use underscore or dash is still okay. Yeah, does not really matter. So hello, cargo new Hello Rust. What it's going to do is that it's going to create a whole new folder called Hello Rust. Now in Rust, they call it crate. C-R-A-T-E. All right. So I'll just go ahead and enter. Now you can see it says creating binary in bracket application Hello Rust package. So that's why you see they say cargo is a package manager. So what it has created like this is your package. And the package, like what is called package in Rust is crate. And they refer to anywhere you hear crate, they are simply referring to a package too. You understand? And every package has a name. So in this case, the name of this package is the name we signify here, which is Hello Rust. So it will create the folder Hello Rust. Then inside this folder, you are going to get another folder called SRC. That's your source folder. And then inside your source folder, you have a file called main.rs. This target, right? Because I have my Rust analyzer. So what it does is that it automatically compiles my language to always check for error. So that's why I see this one appeared immediately. This one is not part of it, right? So let me remove it. It's not part of what will be created. What will be created is the name of your this thing. Inside of it, your SRC, your git ignore. Then inside your git ignore, what you have is this target. You know what your git ignore file means? Anything contained in it, once you push, you git push, it will not go with it. Because this your target is not meant to be pushed. It's meant for your own local machine. Then you have your cargo, just like how you have your package.json. For cargo, you have cargo.toml file. Let me see the full meaning of this. Me, I used to forget the full meaning, but it has a full meaning. Tom something, something, something. I'm coming. Let me check because I have the extension installed so that you guys will see the full meaning. I don't know the full meaning. No. I forgot it. Wow. You should just browse, just try and browse the full meaning of TOML. It's Tom something something.
Minimal language is minimal language like that.
Good. Just like how you have your JSON as JavaScript object notation. So this TOML too has its own. So always take note of that. You can even download this extension, even better TOML, so that your cargo.toml file will be colored like this. At least yeah, like this, it looks better, it looks good. Yeah. So now inside your main file, what will be created is you have your main function, and then you have your print ln to this, right? Then just like I explained, your git ignore, your cargo lock. So your cargo lock is just like your package JSON log 2, right? Where it locks the version of your package and your dependency. Now you can see here under package, we have name, and the name here is hello Rust. The version by default is this, although you can change it. It depends on you. The edition, this one is trying to tell you that it's using Rust 2024 edition. That's what it's using. That's the most recent edition. I think this edition was introduced last 3 to 4 months. Even though formally, like before now, it was using 2021 edition. So I think they say is either they do it after every 3 years, they release it. So the next one we are expecting should be around 2027, or is it even 2028? 2024 plus 3 is how many? 2027, right? Yeah. So I think the next edition we should be expecting is 2027. Yeah. So, but I don't know, they might still change their mind and then release something much more earlier. So this is the structure of your Rust program. And then if we want to run this program, let me see. Let me not go ahead of our time. Right? Okay, no problem. So now, just like I explained, this one is the main entry point of your program, right? You know, it's a compiled language. And for every compiled language, there's always like an entry point. An entry point simply means everything in the application is being run or is being from that point. So that is what it means by entry point. For instance, now if I come and say, okay, let me create another function that, let's say, print name, right? Let's say this function prints my name. Let's say, so print ln and say my name is Phi Tech, right? Now, even if I come to run your program, you can see that here we are not inside this hello Rust folder. We are not inside yet. If I do ls, you can see we are not inside. We are outside of it. So I need to move inside of this to be able to run the cargo command. Because now if I run cargo command outside of it, cargo run, it will not work. You see, cannot find cargo.toml. Because once you run the cargo run, what it does is that it looks for this file, and then from here, it checks the name of your program. And then from there, it will have an idea of how to execute the program. So first, we need to move into it. So we use cd hello Rust. Now, as you can see, we are inside of it. So if I do ls, everything here, you see it here. Cargo.log, cargo.log, cargo.toml, cargo.toml, src, target. So now, if we go ahead, we can now do our cargo run. What cargo run does is that it first compiles the language, the code, and once it compiles the code, it now runs it. If you want to just compile without running, you use cargo build. But if you want to compile and then run it, you use cargo run. So I will enter. Now you can see, what are you seeing here? You can see that it's showing us hello world. It's only showing us what is inside of this main function, right? So for me to be able to get what is here, I need to come and call it inside this main function. So I'll come and say print name. I'll call the function print name here. So I'll run it again, cargo run. So this time around, you can see that it now prints my name is Fitech. But formally, despite the fact that this function is there, do you understand? Like nothing was happening until I called the function print name function inside of my main. So that's why they say this main is an entry point for your program. All right. So that's it. So any question on this before we proceed?
Am I audible?
Yes, you are.
So I think it was Stanley who made mention of something like what I actually meant wasn't that you have to install. It wasn't 100. I said Visual Studio, and I said it is optional, but Even if you want to install it, they will tell you that it is advisable you install Visual Studio. Although you can
Studio.
install Rust without installing Visual. Yes, that was what I said. Not that it is compulsory to
Okay,
install Android Studio.
okay. Visual Studio is different from Android Studio now. So in
Yes,
fact,
now I
our
made mention. I made mention of Visual Studio, not Android Studio, and I said it is
uh,
never compulsory.
yes, in fact, it's even
Okay, okay.
advisable.
I missed that's my the error is from my end. Then I was thinking you were saying Android Studio.
Okay, no problem. Thank you for clarifying. So, well, if you are using Windows, I will advise you to install the VS Code. If not, you might have some kind of weird issues along the line while using Rust. Yeah. So, so that's it. So let's go to the next slide and see what we have. So, writing your first Rust program. In fact, we have written our own already before we got here. So, actually, once you initialize a Rust program, this is the first thing you will see. You will see this one is follow com. All right. So, let me explain this code, what it means. Now, your main, just like I explained, this is your main program's entry point. Without this, your Rust program won't be able to run. So if I come back here and say, main, I no want, let me just name it, let me name it run, right? Do you see what is happening? You can see that it's not even recognizing it to begin with. So that's why it has to be main. So take note of that. Yeah. So that's why they say your main is the program's entry point. Is what the program is looking for. Your print ln, if you observe the print statement we are using, we added this apostrophe at the end, right? This print ln simply means print line. What it means by print line is that if anything you are printing, it automatically creates a new line for you. And that's why you see here, let me show you what is. You see that immediately it prints hello world because we are using print ln. It moves to the next line, and the next one too, we are using print ln. You can see it moved this thing to the next line. Now, if peradventure we say we don't want to use print ln, we just use print like this. So this print does not take you to the next line. So let's run our program and see. So are you seeing what is happening here? You can see that after it printed hello world, it immediately printed the second one. So the difference between this print and this print ln is that the print ln immediately it prints whatsoever you want it to print, it will create a new line. Whereas the print does not create a new line. It prints what you want, but then without a new line at the end. So that's why majorly you see they mostly make use of ln instead of the normal print. Because of course, you imagine this one. Imagine they present you with something like this, and of course, this one is looking noisy, it's looking somehow, but this one is looking okay and coordinated. So take note of that, right? So now in Rust, any keyword you see that has this apostrophe at the end is called macros. And then I know somebody might be say, macros, which is macros again. So when they say macros is like meta programming. It's part of meta programming. So when they say meta programming is like a function that is running another function. So println, a macro is a function that is running another function. So that is what a macro is. So here, what I have here is println is a macro. And what is this println doing? Is running another function. What function is it running? Is running the print function. So that is what macros are, a function that is running another function. So, and you can define macro yourself. Like, yes, there are standard macros, follow com macros in Rust, your println, your print, your assert, and some others. But you can build your own macro if you want. You can decide to say, you can build your macro in such a way, you say, we'll still look at that before the end of the class. We'll build our own macro. Now, println is printing this with new line. We can decide to do our own that. We'll say print jthrough an apostrophe. So what it will not do it, will not build it in such a way, anything we put inside, it will print it, but it will add jthrough at the end. So that is macro. So take note of it. So the apostrophe is not guy. You know the way some of us will say, guy, give me that spec. You wear spec, you wear cap, you are doing big boy. So the apostrophe is not like a fancy something. No, it's actually a macro. That's why you are seeing it. All right. I can as if people are raising up their hand. Okay, Obed, go on.
Okay, good morning, sir.
Morning. How are you?
Okay, can you hear me, sir? Can I
Yes,
say that
yes, I can.
macro is can I say that macro generator that it's generate a code before compiling, that kind of thing?
Okay. Well, we'll see to that. I don't
Okay.
want to say yes, and I don't want to say no, but we'll see to that at the end of the class. You understand? Uh-huh. So what do we have? What do we have? What do we have? What do we have? Okay, so let's go on. But any question before we move on? No, the main goal of the class is understanding. So all right, all right. It means your last teacher did a wonderful job. These are people are not asking question. So variables and mutability, right? Now, of course, I believe all of us know what variables are. All of us know what mutability is. Mutability is just English, programming language and English, right? So now by default in Rust, by default, I believe you guys in JavaScript, you have let, right? And anything you use let, you can change it. For instance, I can come here and I'll say let name. The same name that I use, I can say, okay, now I don't want name to be fitted. I want name to be Rust, right? And then I can now come and say, let me copy this one here. Okay. So let's try it and see. What did these people they talk? Okay, sorry. I've declared it once already. So what I just need to do is just to. So now you can see, initially I gave it name to be Fitech. And I printed it here to show us that yes, name is Fitech. When you got to here, because I'm using the let keyword, I'm able to change the value from Fitech to Rust. I'm printing it here now. It's showing me Rust. Now, this is what is called mutability. When you can change the value that a variable is holding at will. Mutability. Why? In JavaScript, if you want to make this variable immutable, that's you cannot change the value once assigned, then we use const. So now with this, if I run this program, it will certainly throw me an error. Now, why is it throwing me an error? Because here I've already stated that I want this variable name to be constant. I want it to be immutable. Let it not be able to change. And here I'm now attempting to change it. So that's why we are having this error. But in Rust now, right, by default, your let by default is immutable. So if we come to Rust now, right? Okay, let me use browser so that we'll be seeing it live and direct. I think these guys should have Rust, if I'm not mistaken. Aha. Good. So let's say here now, I say let name equal to fee tech, right? And then I now come here and say print ln name, and then I put name, right? And then I run this program. Of course, it print out fitech for me as name. Now, how you print out in Rust is that anything you want to get, you want to print from your variable. If you have a variable and you want to print the value, you have to include this. So once you include this, you put comma and then you include the variable you want to print. So what it's going to do is going to now regenerate, and then instead of this curly bracket, it will replace it with the value of the variable. So either you do it this way or you do it this way, and inside here, inside the curly bracket, you put the variable. So I think both methods works. So either you go with this method or you go with the other method. All right. So now, let me say I come now and I put name. I want to now change my name. Say no, change it to Rust instead, right? So let's go ahead now and print and see. Let's see what it's going to tell us. So you can see, what is it telling us? Cannot assign twice to what? Immutable variable name. So by default in Rust, variables are immutable. They can't change. Now, if you want it in such a way that variables should be able to change, right? That's where the mute keyword comes in. Now, the mute simply means let's mute y. That's you are making the variable to be mutable. So in that case, the value can be updated. So coming back to what we have here, instead of making this one just let name, since I want to change it here, I want to be able to change it from Fitech to Rust here, I will now add the mutable keyword to it. And then once I run this code now, you see that it's now working. For this one, Fitech here, I change it to Rust, I printed it, and it's showing me my Rust. So let me make it changed name here so that it will be different. So you can see. So that is. Then Rust also has a constant. That one is not mutable at all. In fact, if you even attach the mute keyword to it, it will throw an error. All right. So now let's say, and the reason why they had to introduce the const keyword is, you know, there's variables that are constant. For instance, now, if you are doing like a programmable something and you are using the value of pi. Pi is a constant that everybody knows, 22/7, 3.142. So that is where the const of Rust comes in. Not to make something mutable or mutable, but just in case you are dealing with variables that are known to be constant and doesn't change. You understand? So now let's say we want to calculate the area of cycle. We already know that the pi is always constant. So here we can now use the const keyword. We can even do it outside, put it outside of our main. Probably if we have other functions that will be using it, we can put it outside our main and we can put it inside our main, anyone. So it's always advisable to use capital letters for constant. In fact, let me even shock you. Let's try something. I'm going to use small letter and then I'm going to give it a value 3.142. Now, if you observe all the code we have been writing so far, what we have been doing or depending on is what we call implicit infer. You understand? What implicit infer means that the Rust program itself will look at our variable. It will look at the value we give to our variable and then assign to it the proper data type. We'll still come to data type. That's why I don't want to go there yet. So let's wait. Once we reach there, I'll explain more. So now let's run this. Let me say area of cycle. So let me say let area equal to pi times, let's say the radius, right? Let's say pi times radius. So let's give radius a value. Let's say let radius be equal to, let's just say 7, right? So area now will be pi r square. Okay, so times another radius again, because it's the radius is square, right? So let's now print our value. That's our area. So area, and what do we have? Area. So let's run this program and see what we are going to have. So now, are you seeing what it's telling us? Provide a type for the constant. So once you are using a constant value, you must provide the type of that constant. The compiler cannot help you to infer in this case. So in this case, I'm going to add a type. You use your column immediately after the variable, and then you give it. In this case, since we are using decimal, it should be a floating point, although we'll still come back to those. So we can give it F32. So let's run it now and see. Okay, that's true. So let me make this one 7.0. We'll still come back to this. I'll still explain what is happening. Now, what did you see? This is what I wanted you to see actually. You see that because we are using the const keyword, the program, the compiler is expecting us to have our variable all in uppercase to differentiate it from the usual. Okay, imagine you come to my code now. This is my code. If you look at this pi, like it will not occur to you that this pi is different. So you might end up start looking for, where's pi? Where's pi? Inside of your main, you end up not seeing pi. But now, if I make pi to be uppercase, I come here, I use the uppercase. Coming to my code, if you check, you find out that only pi is uppercase, the rest are smaller case. You know that, okay, pi must be special. Something like that. So Rust will not even allow you to use const without using uppercase for the name of your variable. So now that we have changed it, let's run it and see. So you see, now the program has compiled. So any question? So that's why you see here, they say const requires type annotation. If you don't annotate a type, it won't run. And it's always immutable. So any question?
Okay, sir. I think when you were writing that floating number, she said F32, and then on this page I can see F64. What are these types? What are these types?
Okay, we'll still come to that. All right. We'll still come to that. But you can still use F64. If you use F64, it will still run, but we'll still come to that. Yeah. So once we get there, yeah, I will explain. So any other question? But it's a good observation. Shows you guys are following very well. So is Rust hard? Let me ask you guys this question before we continue.
Rust is intriguing. Like, it's just intriguing how deep and how connected the concepts are. Like,
good.
You're just making us love Rust now.
All right. That's good.
I swear, Emerson talk the truth. They just make them very simple. Like say even JavaScript have had pass rush.
Haba. You serious?
Me too. I support that thing where Johnson talk.
Confirm.
All right. So no wahala. Let's continue. So, okay. So we have looked at variables and mutability, right? Now let's go to the next one. Now let's look at scalar types. Now there are different types in Rust. There's the scalar types, there's the compound types. So we'll look at each of these types. Now, the 4 scalar types we have in Rust are integer, floating point, Boolean, and character. Now, for integer, we have 2 different types of integer. We have the signed integer and the unsigned integer. Now, for the signed integer, at the front, you always see them attaching I to it. And then these integers, they are in 2s, in values of 2s, starting from I8. So how are they being measured? If you do 2 raised power of 3, you have 8. If you do 2 raised power of 4, you have 16. If you do 2 raised power of 5, you have 32. If you do 2 raised power of 6, you have 64. If you do 2 raised power of 7, you have 128, up to I size. So although I size basically on most computer, it depends on your computer. Different computers have different sizes for I size. But by default, I size takes the data of the structure of I128. So now, why are we differentiating integers as signed and unsigned? If you are dealing with a positive and negative number, that's you are doing something that you can have a positive number and you can also have a negative number. In that case, what you are going to use is a signed integer. Why, if you are doing something that you know is not possible to have a negative number, like in this case, the number cannot go below 0. It's either 0 or upward. In that case, you use unsigned integer. All right. So these ones too, the only difference is that signed integer, you always attach I at the front. Unsigned integer, you always attach u at the front. So take note of that. So signed, unsigned. Floating point, of course, integers, you know what integers are? They are whole numbers. They are numbers without point, without decimal place. That's what integers are. So floating points are numbers with decimal place. And they are basically two, the F32 and the F64. Now, should you do this? Should we do this? Should we do this? Should we do this?
Yes.
You don't even know what we are supposed to do. You just say yes.
I shall know anything we're going to do is going to benefit us. So anything is yes.
Okay, no problem. So let's do something. Lord help me, God help me, God help me. I'm still thinking whether we should go ahead or leave it.
So what is
If
that?
it will be good for us, let's do it, sir.
Actually, it will be good for you guys, but I don't want to, I don't want to fill your head with many things.
Our head is already filled up. So what's there? Just continue, sir.
Let's go there, sir. Yeah, let's do it, sir.
Okay.
Pastor, ride on, sir.
Okay. I'm still thinking. And you people want me to do it. Okay, no problem. So let's confirm something. Because somebody might say, why are we having I38 and U38, right? So let's look at something. Hope you are seeing my screen, right?
Yes, sir.
Yes, clearly.
Okay. So U8. So let me quickly use this one to explain something for us. Now, if you look at what they said here, right? I8, that sign 8-bit integer, can store values from -128 to 127. Whereas U8 can store values from 0 to 255. So okay, good. I hope they explain it the way I want here. So that now these are done the enter hex. And my problem with these people be that too. They go and just scatter person head. So now okay. So if we look at 256, right? For U8, for unsigned integer, remember what I told you guys? I told you guys that unsigned, it means the number, it only contains positive number, no negative number. So the size of number that U8 data type can contain is just between 0. Let me hide my screen. It's just between 0 to 255. Now, normally or ordinarily, it's supposed to be up to 256. Right? Now, I want somebody to find the cube root of 256. Now, coming. Cube root of, 250. I don't have scientific calculator on my phone. Okay. Cube root, no, this is not what I'm looking for. This is not what I'm looking for. Okay, no problem. So it stores values from 0 to 255. Now, this 0 inclusive. So normally, what it stores is that it stores up to 256 bits, right? 0 inclusive of the bits. Is in numbers. In normal numbers, we used to look at 0, that 0 is nothing, right? But in this one now, 0 is inclusive. So making it to be able to take a total bit of 256. Whereas for I8 is being split into 2. from, if you do half of 256, you are going to have 128, right? If I'm not mistaken, if anybody is with his calculator, because the I8 must represent both the positive number and the negative number, and they must be equal. Two of them must be equal. The U only represent positive. So in that case now, you only have from 0 to 255. Just like I said, the 0 is inclusive. So if you are taking everything in consideration, is you are having space of 256. So, but coming to I8, that 256, you divide it into 2. If you divide it into 2, you have 128. So if you share them into 2, for the positive number, you have from 0 down to 127, making it still 128. Because by the time you take that 0 as part of the digit, that means you are adding that 0 to 127. So you're having 128 from 0 to 128 in the positive side. Then the negative side, you're having from -1 to -128. So that is for U8. Now, let's look at how they calculate the size so that you can be able to calculate for the rest of the thing. It's not magic, all right? It's not magic. I hope these people are clear enough. I hope they are clear enough. Yes?
So I think the description of number line in mathematics
Yes.
is a perfect example of how, number line.
I love this. So for those of you that have done Cartesian graph before, you know you have your y-axis, your x-axis, and your x-axis have a positive side and a negative side. Your y-axis too, same thing. So that is what is happening here for your I, for your sign. You understand? While you're on sign, it does not have negative. So everything, it gives all the space to positive numbers. So if we come to this place, let me show you something interesting, right? So I'll take all these things off. Now, what did we say about I8? We say I8 can only hold a number, right? Up to plus what? 127 and below minus what? 128. So let's say, good. Now let's give it I8. Now in this case, let's give it 129 or even 128. You know, the highest is supposed to be 127. But now we are giving it 128. So let's run this program and see what is going to happen. Okay. Let me print it first. Don't know why this is. Don't mind Rust though. That's how Rust is. Rust is very, very he checks everything. Hey, Rust is like, I don't trust you. So that's Rust for you. Now, what do you see here as the error? You see literal out of what? Range for what? I8. Now, let's change it to 7 and see whether it's going to work. You see, it worked, right? Why? Because 127 is the highest number it can hold. Now, let's check minus 128, being the highest negative number it can hold. You see, it worked. Now, let's take it to minus 129 and see if it's going to work. You see, literal out of range for I8. So I don't know, do you guys understand what I was trying to explain, or what I'm trying to explain? So that's why you see there are different sizes, I8, I16. So if you know the number you want to use, or the number you are using for your program or calculation is beyond what I8 can carry, you move to I16. If you look at it and you see that it's beyond what I16 can carry, you move to the next one, because even I16 has its own too. I16 has its own too. So all of them have their own. All of them. So let's see. Why Google they do like this now, for God's sake? Hi. So look at the range of values that U16 can carry from 0 to 65,535. So now remember, I told you the 0 is inclusive. So total is going to be able to carry 65536. So if you split 65,536, it will give you this number here. So it means from 0 to this number, and then from -1 to minus this number. So that is the difference between the two. So now let's take this number 65,532, right? Let's put it here. Now, one good thing with Rust is that you can always separate numbers using underscore. All right, is allowed. Is allowed. You understand? Just in case, normal the way you write numbers now, you always use comma so that you will not be confused. And maybe between 3 zeros, comma. And in Rust, it allows you to use an underscore to avoid confusion. So either you use underscore or you leave it the way it is. Yeah. So now you can see that we are running it with I8. What is it showing us? It's out of range. Now let's change it to I16. It will still be out of range because I16 must represent the number both in positive and negative. So it's dividing it by 2. But once we change this one to U16, you see that it will take the number. You see, it took the number. But anything beyond this, let's say we now add 3 more zeros to it, U16 itself will not be able to carry it again. You see, literally out of range. So that is why you are having all these different variants. So I hope I'm clear, like you guys understand the basics of all those variants. So if you know you are dealing with a very big number, it means your target will either be I64, depending on whether you are like what you are dealing with is both positive and negative. Either you go for I64 or I128. And if you know what you are dealing with is just positive, there's no point of wasting space for a number that will never be assigned to the variable. You can just go with your U64 or U128. Yeah, so that's it. Now, floating point, we have used it before. Just like I said, is the data type that deals with decimal point, numbers with decimal point. Yes, and just like how you are having these different numbers indicative of different size, how big or how small the number they can contain, is the same thing with this floating point too. F64 can take in a higher decimal number than F32. So take note of that. Now your Boolean, I'm very sure that pretty everybody is familiar with Boolean. You have either your true or your false. And then lastly, your character. I say your character, somebody don't dey fear now. Say, me where yesterday person tell me say I get bad character. Don't be afraid, it's not you. So okay, let's look at the floating point, right? So let's say let's norm. So if you observe for these other ones we did, let me show you. You see that what we are doing is that we are annotating it explicitly. That's by ourselves, we are telling it the data type we want it to use. Now, if we don't do this, Rust will automatically infer. That's what it means by infer. It will check your value and then it will assign the best data type. It feels that this your value will satisfy this your value. So even if we leave it this way and we run, you see that our program is going to run as it should. So take note of that. So also, this same number, once we come and we say is 65.9876 and we run, this one we automatically check. It will say, this thing has a point. Oh, this should be a floating point number. So it will assign it automatically. But let's say, for instance, we give it a floating point number and we are now giving it maybe, let's say U32 and we run, it will definitely throw an error. You see, what is it telling you? Expected what? U32. So since we are assigning it, annotating as U32, the value it was expecting is actually a U32 value. But what is he now seeing? He's now seeing a floating point number. So that is that. So yeah, we can just give it F32, right? And then we run, and you see that it's going to work properly, work the way it's supposed to work. So you can decide to use 64 too. Yeah. So that's that. All right. Go on. Go on, Dali.
Um. Okay. since okay, the other example you give, since you did not annotate a data type to the number and
Yes,
the compiler automatically assigned it to the number. Okay, is
yes.
it like safe to say we don't really need to annotate the data type, or does it have any side effect or like any drawback?
Okay, it does not have any side effect. It does not have any drawback. You understand? Although there are few places where you will need to annotate, but majority of the time you don't even need to annotate. Just assign value and then fire go. You
Okay,
understand?
okay. All right. I
Yeah,
understand.
yeah. So any other question? So now, okay, we've talked about flow. So your boolean, we all know boolean, true or false. We can say let Nahim do wham, right? So here we can decide to say true. So here, if you print it, right, do wham, na him do ham, right? If you run it, can see do wham true. So it's either you use you go your true or your false. So that's boolean for you. So you can see here, we don't need to come here and be annotating that is a boolean. There's no actually need. The program will automatically do that for us. But if you want to, you can still annotate, yeah, by yourself. So that's boolean. Then your character. Now, character type, it supports one beautiful thing about Rust is that its character type supports Unicode. Now, once we talk about Unicode, that's it even goes beyond just alphabet A, B, C, D down to Z. Even your emoji, you know your emoji, your smile emoji, your thumbs up emoji, your celebration emoji, all it supports it. Even all these Chinese character, Japanese, Arabic character, it supports it. So that's one huge advantage of Rust character type. So now, to use Rust character type, you just need to use a single quote, not double quote, right? So let's say a double quote, and it must be exactly one character. If you mistakenly add a second character, it will not work. So let's look at this, right? So let's run this. Now you can see it's showing us letter A. Let's say I mistakenly, even if it's just dot, I add and run, or I add B, or I add C, or anything, or comma. Once I press run, it will throw an error. Why? Look at what it's telling us. If you meant to write a string literal, use double quotes. We'll still come back to this string literal. So far his character, it must just be exactly one. So, and we said it can also represent emoji, right? So let's check emoji icons. Let's find one on the internet and copy. So I've copied this. Now let's come back to our Rust program and then assign it to this variable. Ah, now wow, these people na picture then carry give me. Let me get it from ChatGPT. I know ChatGPT should give me direct. So give me.
Even Twitter, sir. Twitter can give you that.
Okay, Twitter can give me back.
Yes.
Wow. Imagine, give me one, they give me plenty. So let's see if this is going to.
So you added S now.
So you can
You
see,
added
right?
S.
Okay, now true. I had imagine English. It is well. So let's run it and see if it's going to work. So did it work or not? You see that it
It's
worked.
worked.
Yeah. So that is one advantage of using of Rust. Yeah. Let's even try. No, mono use rainbow before somebody will start. They look us one eye now. They say when I don't they fly rainbow color. So
Christiana, which can laugh with that?
So I wonder. So you can see. So you can also use emoji. You can use Chinese. You can this thing language, their characters. It support Arabic character. Support any form of this thing character. It support it. So that's one huge advantage of Rust character. So of course we have played around with all of this, right? And that's why I see here it's telling you F64 in fact, despite the fact that we did not indicate that it's F64, but it's automatically infers it. So that's it. So let's look at any question for these types, these scalar types you've just finished before we move further. Any question? Okay. So let's go on. Now let's look at compound types. Now, the whole idea of scalar and compound is that scalar deals with just one at a time. You are assigning just a single value to a variable, or you are assigning just a single value type or data type to a variable. Why the idea of compound is that you are assigning more than one value to a variable, or you are assigning more than one data type to a variable. So that's all compound simply. So for compound types in Rust, we basically have two types. We have the tuples and we have the arrays. Now, I know if you are into Python, tuples will not be new to you if you are into Python. But from JavaScript, I don't think JavaScript have tuples. I don't know. It might have. I don't know. But I'm sure JavaScript has arrays. Python has arrays. So tuples now can hold values of different types. Now, the major use of these tuples is used for grouping different data. So you know that basically, if you come to this place, what we have been here, if his character I want is only this character, I can only give this one character. But let's say in a situation where I want to write a descriptive, I want to write something descriptive. That is, I want to include a computer. I want to include a description about the computer. I want to add computer icon. I want to add the name, the icon, and also the description, right? I can come here and use tuple. Now, how do you use tuple? You use your normal brackets. Now, from this place, right, you give the name of whatsoever thing. Now, the first one wants it to be the icon. The second one wants it to be the name. And the third one wants it to be the description, right? Now, here, for my values too, I'm going to use brackets. Now, I'm going to make sure I follow it up. So, icon is first in my tuple. Here too, I'll make this icon to be first. Next, name is second. Let's say laptop. Here, I'm going to make the value to also be second. Why description is the final one? Here too, I'm going to make the description the final one. Let me say a Dell laptop, right? So this is what is known as tuple. All right. So you can see that we're able to group instead of description, right? Let me just use cost, and that's the price or price instead of that, so that we have three different data types. So here now, instead of this, I'm going to have, let's say the cost is, let's say 100,000, right? So you mustn't write this underscore before you say, Ross, why be say you can leave it this way. It's just to make it more readable. That's why I'm using underscore. Yeah. So yeah, good. So now this is a tuple. You can see that tuple, it takes in a character, it took in a character, took in a string, and then finally it's taking in a number. So it's taking in three items, and those three items, all of them of different data types. All right. So if you want to print, now one thing about this tuple is that here now, let's say we want to print icon, right? I'll come here, icon. Here, I'll name it icon, right? So let's run the program and see if it will work. So you can see what it's trying to tell us here. It printed it all, but it's just warning us that we have not used name and price. We have two variables that are not used. You can see it. So that is how Rust is. If you have any variable, you are working with any variable that you are not using at the moment, it will always throw a warning error for you. So in that case, if you want to avoid throwing the error, you can read, you can see prefix it with underscore. So you can just add underscore to it. So adding underscore to it, you are trying to tell the compiler that for now, ignore the fact that I'm not using this. So if I run it again, you see that there's no complaint. So now I want to use name, icon name, price. So this is icon. Next, I want to print price. So you can use /n for new line, right? So the next one is name. And then finally, the last one is price. So we have icon first, followed by name second, followed by price third. So let's go on and run it. So you can see icon, name, and price. So do you guys understand tuple now, like how important tuple is? Okay. So this thing that you see I'm doing here, right, is destructuring. I'm already destructuring the tuple. You understand? I'm already destructuring it. If you look at our example here, the example I listed here, it's not like we just assign just a single value to the tuple. Why here we are like destructuring it. So if you like, you can either always do this, just destructure your tuple, or you just give your tuple a single value. But if you are giving your tuple a single value, you must indicate the data type of each of those values you want to give the tuple. So let's say, for instance, this one, I want to just assign it just a name, right? What I'm going to do here, let's say info. I use this thing info. If I run this, right? Let me take this one off. If I run this, it will throw an error. You see, unused variable info. So now let's go back and print info and see if it's going to work. Okay, let me just copy this so that we'll not have to come and then let me take this one off. So let me print info. So what do we have? Info, right? So let's run it and see. So, okay. So now, right, what it's trying to tell us is that it does not implement a standard format display. See all this story, we'll still come back to it. So forget it. But once you see this, in fact, it will even tell you what to do. You see, note, you see, the threat this is not implemented for this. Note, in format strings, you may be able to use this. You see, it's giving you an idea or this. So let's use that. So let's use column question mark. Let's run it once more. So you see, it printed it. This is our tuple info, and this is the values of our info. So this one, this type, and the other one that is having hash. This hash is just to beautify it. It will like take everyone. It will give everyone his own line. Why that other one? It's just print it plain on a straight line. So this is it. Now, if I want to destructure this info, what it means by destructure, I want to now pull off or pull out each of these values into their own individual variables. That's when I will now come here. I will now say, in this case, the first one, I want it to have a name called icon. The second one, name, and then the third one, price. And then it's going to be equal to info. I believe we all know destructuring in JavaScript. So what I've successfully done here is to destructure the tuple. That's I've pulled all the values from the tuple and assign each of them a variable. So if I bring back this function now and run it, You see, so you can see icon, name, and price. So it's just all depends on how you want to do it and all of that. It's not as if doing it one way is more advantage than the other. So it's just left to you. So that's it. So apart from the structuring, the other way, right, you can use to access a tuple is like indexing, but not the kind of indexing we know in array. So let's say, for instance, let me take this one off, right? So let's say I want to access the name, right, or icon first. Let's want to access the icon. Let me take this one off. So icon. What I'm going to do to access icon from this info, right? I just need to make a variable. Let icon equal to, now, what is the name? The name of the tuple is info. Dot. Now, to access the first one, I'm going to use 0. So that's why I say it makes use of index, but not index inside a bracket like array. This one is a dot followed by the index. So now, if we run this code now, let's see what we are going to have. So you can see it was able to pull off the first one. Now, if it's the second one we want, if it's the name I want, the name of the laptop, of course, the name of the laptop, change this one to name, is going to be at the next index. So after index 1, the next the index 0, the next one will be index 1. So I will run it. So you can see. Sorry, not supposed to be icon, it's supposed to be name. Yeah. So you can see it has pulled out the name for us. And then the last one here is the price. If I want to pull off the price from the tuple 2, that one will be now be at index 2. So here we have price. Right? So you can see it has pulled out the price. So any question concerning tuple before we move? All right. But are you guys clear? Like, hope is not too ambiguous. Okay. All right. So now arrays, we all know arrays. So one thing with Rust arrays is that it must be of the same type. Unlike tuple, you can carry character, you can carry integer, you can carry float, you can carry boolean. But for array, all the elements in an array must be of the same data type, and the array must be fixed. What it means by fixed is that before running your array must have a fixed length, or else the compiler will throw you an error. All right. So now let's see. So let's say let's say let letters, right, equal to, of course, for array you use your brackets. So now you can see that this is an array of what? Of characters. Yeah. If I mistakenly now come here and now add a string, right? Let's say, this D, right? Mistakenly add a string, because this is a string. Now, what makes this a string is the fact that I'm using this double quotation. For character, you always use single. Now, if I run this code, I'm not even printing the letter yet. Look at what it's telling me. Mismatch types, expected character, found string literal. So that's it. So all of them must be of the same type. Yeah. So now you see, if we run it, it's going to run. But of course, we are not printing anything. And see, it's even telling us that we are not using it. And we have a variable that we are not using. So, and if it's intentional, I see it's telling us to like bypass the warning. We should add an underscore to it. So we can print this out. Print ln. So if you are printing an array, printing a tuple, if you are printing any compound type, array, tuple, always use that their format standard printing, or else it might not work. So let's see letters. So let's attempt to print it without that standard debug and see what we are going to have. So you can see. So what he's just technically trying to tell you is that he doesn't know how it should print it. You understand? So you have to help it to know how it should print it by adding either this, that's in a situation where you want it to print it on a straight line, everything on a straight line, or you add the hash at the front for it to print it per item, it will list per item on its own line. So either this one or the other one. So, and of course, we know how to access this thing, first letter. So who can help us to access the first letter in this array? What are we going to do?
Dot zero, sir.
Letters, brackets, 0.
Okay. So
That's
It's dot
letters dot zero, not
dot
square
Dot
bracket.
to I beg.
no
dot
problem. We'll go use the two. Right? So this for first. So let's do for second. So let's use SL, second letter, so that will be fast. So that means the second letter will be .1, Abi. For the people that I say dot. Second letter. All right. So let's run our code and see what will happen. So do you see what is happening? No number field 1 on type this. Let S1 unknown field. It's trying to tell you that this .1 is unknown. It said instead of using tuple indexing, use array indexing. So that was what I was trying to explain to you guys, that tuple uses index. Array too uses index method. That's from 0, 1, 2 down. But their method of indexing is different. For tuple, you use a dot. For array, you use your square brackets. So for this code to run, we have to convert this dot to a square bracket. And then once we run it, so do you see now? You see that we're able to get the first letter and the second letter. So any question on that? Hey, Jetro is laughing. Yeah. So I know that tuple will really confuse you guys. So array still maintains its order and all of that. So yeah. So now arrays, right? If you look at this one, what we did here was we allowed this thing to infer our array. We did not indicate the data type, right? We allowed it to infer. But in a situation where we don't want it to infer, we have to specify number one. The first thing we have to specify is the data type. Now, what data type is this that we are representing our array? Somebody help us. What data type are we?
Character.
Good. Then you use a semicolon, and then the next thing you state is the number of elements. Now, how many was the number of elements here?
5 and 4. Sorry.
4. Okay. So once we run this, it's going to run normal. But if you exclude this place and you run it, it will give you an error. Now, why is it giving you an error? It's giving you an error because arrays the size of the array must be known at compile time. Before you compile, the size must be known. So that's why you have to specify it. But if you are not annotating it, by it himself, the Rust compiler by himself will infer that data type, both the data type and the size to this array. So always take note of that. Yeah. So any question? Then another thing, one good thing about Rust is that if you want to create an array with an initial value, you can do that. So if like from your material here, you can see it. You say arrays can be initialized with a single repeated value. And how do you initialize array with a single repeated value? You use value and you use length. So let's say now I want to create an array. Let's say I have 10 students and I want to use an array to store each of their scores. But I don't want to leave the score empty. I want to put 0 first for the scores. Then subsequently, I'll come and be adding it. So now what I'm going to do, I'll put let scores. Now, instead of me to suffer myself and come and say 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, I don't need to do this. What I'll just do here is which number, which this thing do I want from this your material, the value and the length. So which value do I want to use? 0. How many zeros do I want? I want 10 zeros. So if I print this scores now, right? Let me copy this. So if I print these scores now, right? Yeah, if I print this one now. So what did you see? Okay, let me make it to be a single line so that to know. So you can see it created an array of 10 elements, all initialized with 0. So if I want, let's say I want it to initialize with character A, it will do the same thing for me. If I want it to initialize with a number, let's say 67, it will do it for me. So all depends on what you want. If I want it to initialize with a string literal, that's what it's going to do for me. So always take note of, and if I want to infer for this one now, if I want to infer, okay, let me just use character since we have done character. So, or let me use Boolean. So I want it to infer true. So if I want to infer this one, the data type is Boolean, and then the size of the array is 10. So if I run this, you can see. So either you infer by yourself using this, the data type first, the size of the array second, or you just allow the compiler to do the inference for you. So any question before we move to the next slide? All right. So beautiful. So control flow. Thank God all of us are familiar with this, right? So just like your JavaScript, your Python, right? I think your Python is if and elif. Your JavaScript is still normal if and else. And even other languages are still if and else. So it's the same thing too with your Rust. So you can always use if as a control flow to check for either true or false of an expression. So for instance, now we can come here and say if letters at index 0 is equal to what? A, right? What should it do? Let it print
True.
true, okay? True, right? Else, else does the opposite of if. That's if it checks this condition and because if always check for true. So if it's true, if the condition or the expression turns out to be true, the block of if will always be executed. But if it turns out that is not true, that's where else comes in. So once this is not true, we want you to now print
Print
lie.
you a lie.
How comes me and Christiana mind they work like this?
I tell
So
with you, sir.
correct. So if we run it now,
Christiana, what are you doing? What are you doing?
so now if you check, you find out that yes, at index 0, obviously our value is A. So this one turns out to be true. That's why it's printed true. But if like we change this one to, let's say at index, let's say 4. No, this one is not up to index 4. So let's say index 3, right? And we run. You see, of course, this is not a true statement. This expression is not true. So as such, it's going to execute the else block, which is what? Now lie. So it's just your usual if and else statement like that. So any question on control flow? If and else control flow. Hmm? Anyone? All right. So now in Rust, you have if and else. Then there's another control flow called match. Now this match, it works just like switch. I believe you guys know switch in JavaScript. I think Python too has switch, if I'm not mistaken. So it works just like switch. And one thing about this, what are they calling it? This match statement is that by default, it is exhaustive. Exhaustive. What it means by exhaustive is that it handles every case there's at its disposal. Just like how you also have your switch statement, which now has default, just in case none of them work, then the default can kick off. So with match statement too is the same thing. Then by default, if none of them are there, by using this underscore, you are trying to tell that if neither one or two, if there is neither one or two, if it's any other thing other than one or two, just go ahead and execute this. So that's where this underscore comes in. So the underscore is more like your default in switch, where once the value is not equal to anything in the switch, you just go ahead with the default. Yeah. So let's look at this match, how to make use of this match. So from here now, we can decide to say we want to match. Let's say let letter equal to letters. Let's give it index of 2, right? And then let's now use match. Let's say match letter. Now we are matching letter. And then we are now saying, okay, if letter is A, you use arrow. So what you're trying to tell that is if letter is checking, if this letter is A now, you are telling me to execute what we follow immediately after the arrow. So you can say print ln I am A, right? Then you use comma, you don't use semicolon. The reason why you are using comma here is that this is not the end of the statement. Your main statement is this match. So everything inside match is like a variant of possibilities, what is possible. You understand? So you don't use semicolon because semicolon is used to show end of an expression. But this one is not a complete expression yet. We need other sub expressions to make it a whole match statement. So use comma. Now the next one we have is B, right? So B, and then let's say print ln. Let's say I am what? I am B. Now let's try to run this program and see what we are going to have. So are you seeing what is happening? What do you see here? You see, it's telling you there is what? Non-exhaustive patterns. Note, the match value is of type char. Ensure that all possible cases are being what? Handled by adding a match statement with a wildcard. Now, this is a character. For me to be able to use match, I have to match all the whole character in this world. But here, what I'm even looking out for is just 4 characters here. So it means that I just want to check for A and B. Outside A and B, I don't want to check for any other thing. So this one is telling me that I can't just go and check for A and B. I have to add the one that just in case I don't have A and B. So that is where this underscore comes in. Just like I said, the underscore is like the general that, okay, if you don't have, if the letter is not A and is not B, it can be any other character in this world. What is matching is character because it identifies each of these values to be characters. So this using this match statement, match is more like I want to check every single character in this world. So what it means is that it's going to want to check all the old Japanese, the old Chinese, the old emoji, character, Ross character except emoji. You understand? But this one is a way of we saying, Oga, check A and B. If it's not A and B, then just help us execute waiting day here. So we can say print ln, say I know the among, right? So this one, so either you put comma or you leave it, since it's simply the last one. Sorry. So let's run this one and see. So you can see it's telling us that what? I know the among. Why? Because at index of 2, what we have is C. And we are not checking for C. We're only checking for A and B. So if we decide to come and add the check for C, right? We can say it should print Namibi is C, right? And then let's run it and see. So you can see Namibi C. Why? Because now C is among what we are matching. And we are telling that once you match C, just go ahead and execute this. So that is one of the uses of your match statement. So any question? Any question? All right. So don't mind me. Sometimes you see me using examples that are different from what I put here. You understand? It's just, I don't know. Yeah. So, but they're all the same thing actually.
No, but it helps us to even understand more better, actually.
So at least. So let's look at the next one, which is loops. So I believe you all know loops from JavaScript: while loop, for loop, and which one? I think there are 3 loops. Wa? Is it 3 or 2 we have in JavaScript?
3.
Do why?
Do while.
Do while. Thank you.
Like
Do
5.
exactly. So thank you. So now in Rust, they basically have 3 kinds of loop. You have the for loop. That for loop now in Rust, it works just like JavaScript, where you can go over an iterable item, right? So anytime you hear they say iterable item, it's simply item that has more than one value, that you can move from one value to another value. Yeah. So why the while loop? That one requires an exit condition. That's the way you condition while loop in order for it not to keep on running, is that you give it a condition that when it gets to this condition, the while loop should be satisfied. And then you have the loop. That one, the name is just loop. So that loop now, the only way you can break out of that loop is using your break statement. The only way you can exit. Although even while, both while and for, you can still exit. So far as a loop, you can always exit it using break. But this loop in particular, the only way you can exit from loop in particular is using break. While loop, you can exit from it setting a condition. You must not introduce break. For loop, you must not introduce break. But loop, for you to break out of loop, you must introduce break. So let's check. So let's look at this. Let's use for loop. Now, this is an array, and this array is iterable. How is it iterable? It's iterable because it contains more than one item, and we can move from one item to another item. So if we use for loop, right? Using for loop, we can say for L. So L simply indicates letter. Either use letter, L, anything you want to use, right? So me, I'll use L. So for L in, now the name of our iterable item here is letters. So for I in letters, what do I want it to do? I want it to print the letters themselves. So of course, we all know what is happening here. For I in letters, it will start with the first one, the next one B, C, until it gets to the last one. So I'm not even sure if this one will run, as if there's still something we need to do, but let's try it anyways and see. Okay, it ran actually. Wow, awesome. So now you can see it takes the first one A, it comes here, it prints it out, letter A. Next, it takes the second one B, comes here, print it out as B. Next, it takes C until it gets to the last one, which is D. So that is how you use your for loop. So the other example you see that was attached is actually you actually using loop to go over numbers. Now in unlike in Python, in Python, to have a range of numbers, let's say from 0 to 5 or 1 to 5, you need to use the keyword, the range keyword, right? You do something like this, range 5. And this range 5 will give you something like 1, 2, 3, 4, 5, right? But in Rust now, the way they indicate range is either start, dot, dot, stop, or start, end, or start, dot, dot, equal to end. Now, in this case, if you have something like, let's say, 2, dot, dot, 6, what this one is going to give you is 2, 3, 4, and 5. It will never get to the last one, which is 6. But now, if we do 2, dot, dot, equal to 6, what is going to give us is 2, 3, 4, 5, and 6 itself. So that is the difference between just ordinary, just dot, dot, and then dot, dot, equal to. So let's say we want to now loop through from 2 to 6. It's just for us to say for n in, or number, or norm, anyone, for n in 2, dot, dot, equal to 6, right? Print ln number. So print n, that's print the numbers individually, and then I run it. So you can see number 2, number 3, number 4, number 5, number 6. But once I remove this equal to from here, it will just print from 2 to 5. So are you guys understanding it? All right. So that's for your for loop. Then next, your while loop, right? Just like we say, your while loop, you need to state a condition. So we can decide to say, here, to use while loop here. How many elements do we have? I say elements. How many was the length of this? The length of this is 4. We have 4 elements. So it means you have to give it a condition that once it's running, it should run just 4 times to print out this 4. So we can decide to say, while okay, so let's first create a variable and let's make it mutable. No, let's not even make it mutable first. Let's say let I equal to 0, right? Let us start from 0. So let's now say while I is less than letters dot len. So in JavaScript you use, is it dot length, right, to get the length of whatsoever thing you are working on. For see, I'm to say TypeScript. For us, you use dot len. So let's check it. Let's confirm. So let's say letters dot len. Yeah. So I'll just take this one off so that to not throw error. Then let's run it and see. So you can see it gave us the length. So this is the keyword for us, dot len. So it gave us 4. So I'll bring these ones back. And then I'll take this one off. So we say let I equal to 0. This I now will be like our counter. So we are now saying, so far our counter is less than letters dot len. What should happen? It should print our letters for us individually. So yeah. So individually. So in this case now, that's letters index. It's array. To access each and every one of them, we have to be using index. So since I start from 0, we'll start from the first index, 0, 1, 2, and 3. So 3 is less than. When it comes back again, I will now become. Now what it means here is that If we mistakenly run this code as it is like this, it's going to run. But the problem is that the condition to make while loop to stop looping has not been put in place. The condition have been put in place, but it has not been implemented. Why? Because here I is 0. For I to get to a point where it will stop, I have to be equal to letters.len. So in that case, it means we need to be increasing I for every while loop that runs. So if we mistakenly run this one, it will just keep on running. You can see. It will keep on running until to get to a point where you see execution halted. They even stopped it. If I was running this on my system, that's why it will keep on running until it hits my RAM and then crash. The program crashes. All right. So that's how it will just keep on going. So that's not what we want. So it means here we'll be incrementing, right? We'll be incrementing I by 1. I know somebody coming from JavaScript, you say, sir, just use I++ now to increase it. Now, Rust does not support something like this, at least not yet. I don't know whether in future release it might support, but for now it doesn't. So if we run it, it will even throw an error. You see, Rust has no postfix increment operator, not a valid postfix operator. Instead, so you see what they are telling you. So this is what Rust actually supports. So, and I believe we all know what that one is. So I have plus equal to 1, right? So let's run it. So what is he saying here? Now, who can tell us why is it that this program is not running? Like, why is it not running?
Because it's immutable.
Hmm?
You're
We
trying
have
to
to add
mutate
mute.
I. Because you're trying to mutate I.
Okay.
So I is immutable. So you need to add mute.
Good. So,
He did not declare it as a mutable variable.
good. Thank you. So if you look at when we started, we're like, by default in Rust, all variables declared are not mutable until you add the mute keyword. And one good thing about the Rust compiler is that it sometimes even helps you, tells you what the problem is, not just what the problem is, but also like try to give you a solution to the problem. So now let's try it once again and see. So you can see that we are now able to loop through these our letters and all of that. So this is while loop in action. So just know that for while loop, for 4, we don't need to care about all these things. For 4, we don't need to care about whether the thing will just be running infinitely. No. But for while loop now, we need to take care of that. So for if you are using Rust, you have to check the use case. Is it for loop? Is it while loop? Which one are you using, and why should you use it at that point in time? So the last one, loop. That one, it will keep on going on until you indicate that it should break. So if we say loop, and then we say this loop, let it print, let's say Rust, right? And then we just run. So you see, that's why to keep on printing Rust until it stops, right? So in this case now, we need to bring in something. So we can say, okay, we want this loop to print Rust 10 times, right? So we can say, okay, let mute, because we'll be adding to the counter, let mute equal to 0, right? And then here, we'll now be checking if I is equal to 10. What should you do? Who can help us?
You break out of the loop.
Beautiful. Break, right? So here we are telling it that once it counts this I, and of course, since it's counting the I, it's checking if I is equal to 10. We need to be counting the I anytime the loop is being run. So here we now have I plus equal to 1, right? So if we run this now, you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In fact, we can even add the printing of the number. We can say Rust these times, right? And then we add I here. So that once we run it, This is Ross 0 times one. This one we can say +1 so that it will not start from 0 since we don't read in terms of array. uh Ross 1 times, 2 times, 3 times, 4 times, 5 times, like that. So any question for loop? Okay, nobody wants to ask question, no problem. Time is coming, I'm going to ask my own question. So any question before we move, because anything we are doing now is we are moving away from this. Now we are going to functions. So if there's any question from what we've done so far, anything you need more explanation. All right, so seems everybody is okay. So now functions in Rust, of course, if you are, so far is a programming language, you have to have a function. Very important. So in Rust, in JavaScript, you use the keyword function. In Python, you use the keyword def, that's def, like that. So in Rust now, you actually make use of fn to define your function. So you make use of fn, followed by the function name, followed by the function parameter, if there are any, because it's not a must for a function to have a function parameter. For instance, this function we created here does not have any function parameter. You see, it's empty. But it has to be the keyword fn, it has to be the name of the, followed by name of the function, and then even if it does not have a parameter, you have to still indicate these two brackets. And then, of course, your curly brackets, that's the block of code that should be run once this function is being called. All right. So now, one thing with function, unlike, for all these things we have been doing, we have been inferring, that's we have been depending on our compiler to tell us to like infer the type for us. So we have not been doing things like this one now. We did not come and say char semicolon 4. This one we did not come and say maybe let's say you 8, right? We do not do all of this. Now for function, you have to do all of that for your function parameter and your function return. If your function has a parameter, you have to indicate what is the data type of that parameter. If your function is going to be returning something, you have to indicate what data type is that function returning. So, and one beautiful thing about Rust is that you can return values either explicitly or implicitly. Now, when you say explicitly, it means by using the return keyword, just like how your JavaScript. Whereas if you say implicitly, you don't need to indicate return. You just put whatever thing you want the function to return without semicolon. It will return it for you. So let's look at the greet function and then the add function, right? So what should we use? Should we use this, or we should continue with our online? May I still enjoy this one? Oh? So which one should we use? Which one should we continue? Eh?
Anyone that will be faster.
Okay. Cool. Good. So now we said functions. So here I'm going to create a function called add, and the function is going to add two numbers, and those two numbers are going to be integers. That's integers that support both positive and negative. So it means that I'm going to have I. So what should we use? Should we use I8? Should we use I32, I16?
I8.
Okay. So I8, and then the second variable will be adding I8. So, and then now, this our add function, if we want it to return something, we have to indicate this arrow, your dash, and then this your greater than symbol, right? And then you have to indicate what data type is it returning. Of course, if our two parameters are I8 and I8, we are expecting that it should also return an I8. And then next, our block of code. So if you remember, we talked about returning explicitly. and implicitly, right? So if you want to return explicitly, we'll just say return A plus B and then your semicolon. Whereas if you want to return implicitly, that's implicitly means without using the return keyword, we'll just remove this semicolon and remove this return. So by leaving it like this, Ross knows that we are trying to tell it that it should add A and B and return it back as a value for us. So now remember what we said. Even if we run this program as it is, it will not work. Why? Because for everything you are doing, remember your main is always your entry point. For your program to run, it will always run through your main. All right. So let me use VS Code for those that will be using Terminal. I know that some people might not have the leisure of time to be using online. So we do our add function, right? We use I8, I82, and then also we want it to return I8. So here we will return implicitly, right? So here now, I want it to, okay, permit me, let me say, let me add a new line first and say, this is my cross calculator, right? So by using this one twice, it's like I'm telling it to create a new line 2 times. So I'm going to call my add function here, right? I'll say let me give a value of A and B in tuple, right? A and B, and then let me give it, let's say the first one, A should be 7 and B should be should I say 9? Yeah. So here now, here what I'm doing is I'm destructuring this thing, and then here I'm now going to call my add function and add A and B, right? Now remember, now do you guys see what is happening? Now I will uncomment this add. Now what did you see here in line 3? What did you see? You can see that the compiler is trying to good. Go on and go on, go on.
Like unused variable, unused function and unused variable.
Good. Now, not even that one. Check beside A and B. What did you see beside A and B?
It's inferring the data type by itself.
Good. So you see, it's inferring a data type of I32 for both. But immediately we now add them to our add function. What did you see?
It
You see
automatically
the
removes them.
It automatically changed it
you
also.
see that
It's in
good. Good. You see that it automatically changed it to match the data type signature of the function. So that is what inference does. If, for instance, I do this, and I give it I32, right? This one too. I give it I32. Believe me, right? I will not be able to use these 2 variables here in this my function. Why? Because this one is of type I32, whereas this one, I'm marking it that it should be of I8. So that is one advantage of inference, actually. So you can see it infer it because it checks. You see that what this function is accepting is actually an I8. So automatically it now gives these 2 values a value of I8. So here, of course, by this, I'm trying to say I'm expecting my add function to return a value. So since this add function is returning a value, I can store that value is returning into a variable. Let me name the variable result. So you can see, of course, what I'm returning an I8. That's why here it automatically inferred the result as I8. So next, I'll print out my result, right? So result, and then result. So now to run this my program, I just need to use cargo run. So you can see this is my Ross calculator. Of course, that's what we first printed. Then result. What do we get in our result? 16. Because definitely if you do 7 plus 9, it should give you 16. So if I like, I can come and say, no, I don't want to return I8. I want to return I32 instead. Now, this is going to throw an error. Why is it going to throw an error? It will throw an error because these two are I8. So there's no way I can return I8 as I32 just like that. So if I want to do this, I need to do something. Now, how can I do it? I can now use the as keyword, right? So once I use the as keyword, okay, this one have to be single. And it has to be just one number for me to use I32. If it's 2, it will not work. It has to be 1. Yeah. So if it's these 2, what I can do is that for each and every one of them, I can use as I32. So what this one is going to do is that it will take this A, which is I8, and represent it as I32 data. It will take this B2 and represent it as I32. So in that case, adding these two, I'm able to represent them as an I32 data type. So you can see that this one does not have any problem with it at all. It's taking in my 2, is inferring I8 to them because that's what I want. And then the result that this one is returning I32 is also inferring I32 to it. So that is how you do. And apart from using I32, you can use, I think, the into method too. Can use does into works? Does it even work? What is it complaining? Type annotation, multiple implementations, blah blah. Forget all this error. So you people should forget about this one. But into 2 is supposed to work. I just don't know why it's not working in this case, but no problem. So that is another way you can actually play around your types. So, but don't mind me. It's just so you know that, okay, something like this exists. So I'll just take it back to the normal. So just like I said, this is how you return implicitly. If you want to return explicitly, use your return keyword and you add your semicolon. So if you do this, you still end up having the same thing. But most people, just like instead of typing return and adding a semicolon, most people, you just see their function like this, or their code, you see it like this. So any question? Okay, go on.
So sorry, sir. No, open the VS Code. Thank you. Yeah, the VS Code. Yeah.
Okay.
So now, whenever we, let's say, on testing on our terminal now using this function main. So if we are to test this our add function, we must use tuple to pass in the parameter values, right?
Okay, you mean this one?
Yeah.
No. You mustn't. It's just me just trying to play around. Here, you can even pass the value here directly if you want to, directly inside the function. Look at it.
Okay.
So it's like you can even pass it as array if you want. If I want self, I'll just say let num, right? I can even pass it as array 7 and 9. So it's just based on what you want. You understand? Here I have num at 0, and then here num at 1. So if we run it, you see. So it depends on what you want. You can freestyle, like you are free. Just anyhow you want. So any other question? Okay,
Yes,
Christian.
sir. I have a question, sir. What you are trying to say is that if we are writing a contract now that has like 8 to 10 functions, we must pass it in the main. It's by force.
Good. Now it all depends on the structure of your program. You understand? You can do it in such a way you just pass in a single function inside your main, but the flow of execution of your program might be that, okay, the flow of, let's say we have add, subtract. Okay, no, let's say we have function 1, function 2, function 3, and function 4. I might decide that I'm calling only function 1 in main. But before then, I will call function 2 in function 1. And then I'll call function 3 in function 2. And then I'll call function 4 in function 3. Right? So don't mind all this function, this in function, this. What I'm just trying to say is that I can have something like this, right? Main, inside my main, right? I'll say, okay, inside my main, oh, I'm calling function 1. But inside of my function 1, no, if I'm using this example now, it might get confusing. Let's do it practically. So we have add. Let's say I want another function that prints our answer, like a dedicated function that prints our answer. So I'll just say function print result, right? So let's say this one takes in the result, R, right? And then it print out. It doesn't return. It just prints. So, and it prints it, right? Your answer is R. Yeah. So, let me add new line here. So this one we just take, okay, we have to, of course, the result we are expecting it to be I8. Yeah. So you have to give the parameter. So now this function, I will not call this function inside of my main. The only function I want to call inside of my main is my add. But in the flow of execution, I will call this function inside of my add function. So in this case now, I will make this one, I'll say let result be equal to a plus b. So it will add a plus b and store it inside this variable result, right? Then I want it here now. Now this one, I don't want it to return anything. Since already I have a function that is dedicated to printing whatsoever my answer is, I don't need this again. I need this to call what? To call my add function. In this case now, I don't need to store it inside result because the add function is no longer returning anything again. So here now, inside of this add, I'm going to now call this my print result function. And then I will pass the value of result inside of it. So how many functions do I have now inside of this my file? I have two. I have add, I have print, what? Result. But I am only calling my add function inside of my main function. I'm not calling the print result. But if you look at it, you find out that, but I'm calling the print function inside of my add function. So you can do it in such a way, you are only calling one thing in your main. But every other function, they are in a way calling themselves. Then the main function is now being called in the main. So as that function is called in the main, it indirectly executes those other ones that are down the chain. So now let's run our program and see if it's going to work. So cargo, let me clear first. So cargo run. Now what did you see? You see it printed this.
Yes.
It now comes to this. Now it now call this add function. It's passing the two parameter. On coming here, the two parameter, it took the two, 7 and 9, add it together, which is 16. Store it here. It now call the add function itself, now call the print result function. It pass in the result, and the print result function here, what I did was to add 2 new lines. That's why you're seeing 2 new lines here. Your answer is then, of course, the value that is being passed into it, and then 2 more new lines. So I don't know if you understand now.
Yes, sir. I understand now.
Okay.
So, sir, for me to get you, is either you do this,
Yes.
like or you call them separately in the main function, right?
Exactly.
Okay, so
Yeah. So any other question? Okay. I know say Jethro don't they eat food now. That's why I no talk. Oh. Jethro, God is watching you. Okay. So let's go on. Let's continue. So ownership basics in Rust, right? Now, this is one of the core feature of Rust. So I'll try to explain it as simple and clear as possible. Now, when we started, I talked about how other languages makes use of um, uh, what is even the name? Garbage collector, but Rust does not. Now, how Rust manages memory? It manages memory by using what we call ownership and borrowership. So after this ownership, I think the next thing we are going to look at is borrowership and borrowing a reference in Rust. So, but let's look at ownership first. Now, how Rust works is that you can only have one owner, one single owner, but you can have multiple borrower. For example, Obed has a car, right? Or Jethro has a car, or okay, let's use Fitech. So, for example, Fitech has a car, and then Jethro wants to travel with the car. He can go to Fitech and say, please, oh, you should borrow me your car. I want to use it to travel. And then Jethro used the car to travel to Jos. And then probably Obed went to Jos, like he was in Jos at that point in time. And then Obed got to find out that Jethro came to Jos with Fitech car, and probably Jethro is not coming back to Kaduna anytime soon. So Obed can be like, Fitech, please let me borrow me your car so that since I'm coming to Kaduna, so that I'll just drive it and bring it to you back in Kaduna. Now you see, the borrowing now has moved from Jethro to now Obed. So Obed is now able to borrow the car, but the owner of the car still remains Fitech. So that is how ownership works in Rust. Only one single owner, only one variable owns a value, right? If the owner of that value changes, the old owner is no longer valid. Like, it means that Rust will take it out of memory. So that is how Rust tracks memory usage. So let's look at a situation here, right? Let's use the browser in this case. Okay. So let's say we have name, right, equal to string from. Now I know so many people say this is the first time we are using this fee tech. Now, if you check all the ones we have been using before, that type is called a string literal. And this is how they represent a string literal. Is of type, is of data type. This is the data type of string literal. And str, right? They call it string literal. Yeah. And yeah. So why this one that I use string from, and then of course fee tech, this one, the data type is called a string. So there are two different types, very similar but different. We'll still come back to this. So but for now, these are consigned. So what we have done, this is a string, right? Now should I explain this? Mm, 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 mm. Okay. Oh, now there are two sections of memory in a computer. right? There is the, see me, I've even almost forgotten self. Let's confirm. And I just remembered now, and I forgot to say, let me not crack my head. The hip, good. I just remembered now. So we have the hip, and we have the, who can help me remember the other one? I guess you guys should know now. So is this dark mode okay, or light mode is better?
Is this slot, sir?
Hmm?
Is it hip and slot, sir?
Okay. There's a name for it. I'm struggling to remember. Okay, let's just check. Keep stack. Good.
Yeah, stack.
Stack. Good. So there's the heap and there's the stack. So now the stack, you see all those static, you see those static data types we did. Where are they, Seth? This scalar type, sorry, we did. All of them are stored in the stack part of the memory, these scalar types. But once you start coming to compound types, there are types that are called compound types, and this string is part of it. This string you are seeing is part of those compound types. So those compound types, they are stored in the on the heap. So string is stored on the heap. Now, all those compound types that are stored on the heap, the reason why they are stored on the heap is that they can increase. We'll look at other types too that are stored on the heap. They can increase in size at any time. Let me see. I will try probably on Saturday, right? During deaf hour, I will do a detailed explanation. I don't want to just bug you with so many things that are not very closely related. So we'll look at heap and stack very well, and then understand this issue of ownership in Rust. So just remind me. All right. So string is stored on the heap, and for all data that are stored on the heap, you can only have one owner. So if you are giving the value of that variable to another variable, what Rust is seeing, like in Rust I now, what you are trying to do is that you are moving the ownership from their variable to the other variable you are giving the value of that. So for instance, now here I say let name be what? Quitek. If I come back now and say let new name be equal to name, what I am doing here is that I am moving the value from name and moving it to new name. And for that, Rust will no longer consider this name to be valid. So let's check and see. Let's print name. You know, in JavaScript is normal. In JavaScript, I can come and say here, I can come and say name here, right? Let's say let name. Then I can come and say let new name and assign it the variable of name. Now, after doing this, you see that I'll still be able to access both of them, name and new name. If we print this one, you see, if I'm coming name so that we'll know what we are doing. And then this one, new name. Right? So if we print, you can see that we can still access both of them, right? Both the name and then this name. But Rust is not like that. Now, why is it possible in JavaScript? JavaScript makes use of garbage collector. So once it will be checking until when you are done with everything, then it will clean up the memory. But Rust is not like that. Rust, at every point in time, you can only have one owner, but you can have plenty borrowers. But we are yet to reach that borrowing aspect. We just want to look at ownership. So now, because of we can only have one owner, if that owner decides to give his value to another variable, that owner will automatically cease being the owner of the original variable. So now, to confirm what we are saying, let's try to print name. From here, we assign name. Here, name, we assign it the string VTech, right? So in fact, let's even print it. Print ln, so that we'll see what we are doing, right? Name. So this one, I will comment it out for now. So let's run it and see if we get a value. So you can see we got a value, VTech. Now, what I'm now doing here is that I now assign this name. I now carry it and give it to this one. So if I try to access this one after doing this, look at what Rust is going to tell me. So name, right? So let me run it. Now, what did you see? What is it telling us? Borrow of move value. He said, let's name this move occurs because name has type string, which does not implement copy threat. So what he's trying to say is that for me to carry this value and give it to this value, because of you can only have one owner of a value at a time. So a move has occurred. I have actually moved the ownership from name to new name. So here you can see Rust is trying to give you a solution. Now in a situation where you don't want to move the value, what you can do is that you can clone the value. So what is cloning? Cloning is you recreating this value in the memory and assigning it to this. That is what cloning is. So now once we use this clone, if we run it, you see that this one will be accessible. You can see that both of them are accessible. Why? Because this value that I clone to give this one is different from what is here. So I did not move this value. I just clone it and give it to this. But in an event where I'm not using clone, what I've done is to move the value. I've moved this value from name and I've given it to new name. That's why I cannot access it. But after here, I will be able to access new name. And new name will give me the exact what is here. So if I access new name and I run, you see that I'm able to access it. But anything after the move that occurred here, I will not be able to access name. Before the move happens, I will be able to access name. But immediately after the move happens, I won't be able to access name. So I don't know. Is that clear?
Sir, please repeat that last one you said. That last thing you said. I didn't hear you.
Okay. So now, if before this I do this, what I'm doing exactly, because just like I said, Rust, you can only have one owner at a time, owner of a variable at a time. So if I try to access this name after moving it to this new name, if I try to access it, I will not be able to. I can only access it just before the move, because this is where the move happens. Move happened here. This is where the move happens. This is where I actually carry this name and give it to this new name. So anything before this, I will be able to access this my name. But once I cross here, I will not be able to access name again. Why? Because the value of name have been moved to new name. So based on Rust model, name no longer exists. So if I come now and I want to print name, I will not be able to look at what he's going to tell me. I will not be able to access it. You see, it's telling me that move happened. Okay, value moved here. So why? Because I've already moved the value of name here. So immediately I moved it here, Ross no longer see this name as a valid variable any longer. But just before I move the value, just before the move occur, you can see that I'm able to access it. So is that clear? But hope you guys understand. So that is Rust borrow ownership model. Yeah. So any question from what we have done, because I see that it's almost time, and honestly, I don't want to use more of your time. But this is what we are supposed to do next. All right. But I will leave it for next class. Let me see how many pages do we have. Okay, 16. So we have like 3 more pages to go. All right. Let me see. Okay. Option, result. Okay. Yeah. The question mark operator. Okay. Yeah. No problem. So any question before we wrap it up? Any question? Any contribution?
I will really get access to this material.
Definitely. 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 So any other question?
It's just good to have you back, sir.
So, but hope you guys are understanding Rust. So you see that Rust is not, you see that Rust is not hard, right? Like, hope you guys are understanding it.
Yes, sir.
Oh my boss, we are very
So just be
grateful.
our permanent teacher. Just be our
Yes, sir.
permanent
Just
Last
be
teacher.
week
our
we know
family.
they here.
We all lost last week. So today, like this,
Last week no be here we do.
I tell you. Last week class, I dey see am for my dream. They pursue me with stick.
It is
seriously, sir, you are doing a very good job. I really like it.
Honestly, sir. Sir,
thank you.
I feel like you should teach in a university or something like teach
Really?
tech.
That no,
When there's money,
no,
when there's money,
no.
there, what is he doing in the university? No. So now that can pay more than 7 lecturers.
No, not in Nigeria. Oh, like in Cambridge, the
No,
US.
no. Men they teach us Nigerians.
Make una say me go teach for protocol. One kind protocol there for blockchain. Are you bring him down? Personality, is it?
It is well, oh, it is well.
Sir,
Man,
can
So
I be your mentee? I want to be your mentee.
don't
He's
mind
already
me.
our mentor now. He's already our mentor.
I say outside here, oh, personal dealings.
Anywhere you go, he's already our mentor. So you can ask him questions outside the class and he will respond to you.
Definitely,
Okay, sir,
definitely.
you there, ba? Say
Yes, I
you will
did.
respond.
Definitely. I will.
This one a special application. No?
Don't be smarty.
Oh, the rose enter. Oh, finally.
Finally. Yeah.
I swear, I'm gonna lie. I really learned a lot, man. Like I am coming from United States. I've never seen any mentor like Mr. Gideon. Wow.
No be
That's
me. No be cabin be this.
Don't
Actually,
be
I
No
think
guiding
what
me.
be
General
cabin
is
share
trying
be
to
this.
before you're not you know you talk for class. Now you don't dey talk.
Na Ross make Akanemo change accent like this.
Oh,
Actually, today's class was fun, man. I easily gained everything. I understood everything. Like it was just flawless.
Yeah,
honestly.
I love that. I love that. So Rust is not really difficult, right? Um, the thing is just practice. That's just the truth. Even me, when I started, honestly it was not easy. And the whole memory model, borrow, it was looking strange, but with time, like I now understood that wow, this thing is not really as difficult as it looks or it looked and all of that.
So
Uh,
compared to JavaScript, which of them is harder? Rust or JavaScript?
well, uh, I learned Rust. I learned JavaScript before Rust, so I don't know. I shall just know that I feel Rust is more direct than JavaScript. Yes, I feel Rust is more direct.
That's a very good news, oh. Because Rust is going to stress someone like JavaScript or more. Another wahala
No.
be that.
Eh, so it's so nice having you guys back. Honestly, I won't lie. I miss the class.
Yes, yeah, we miss you so much. We've been praying for your return since. So yeah,
We are going to
We
talk
miss you,
to we are going
die.
to talk
yeah, yes, yeah.
taking us the class. I will
So
talk to fighting. Be our permanent tutor.
Yeah, that just be our permanent tutor. We like it.
if I'm your permanent tutor, I will know, if I'm teaching every day, I will not, it will get to a point where I might not be able to give you the very best. You understand? So
Yeah,
that's why
we like you like that.
it's okay. Oh. So
If it's specifically for us, only us. That's us.
hopefully, I think. Oh,
Then maybe during Cairo we will change.
so do you have
Yes, even Cairo.
or till next tomorrow? It's all right. So no problem. So let's see. I don't know. Our next class, I don't know how comfortable it is probably for you guys in the evening because our next class might be evening. Because from tomorrow, I don't know those in Kaduna. There's one lighting boot camp that will be attending. I think it's starting tomorrow, Wednesday, Thursday, Friday, Saturday. So I don't know. Our next class will likely be in the evening, probably anything around 6. So I don't know how comfortable you guys are with anything around 6, 7. So because the
I'm
boot
good
camp
though.
is 10, and I think the boot camp is
7
from
p.m.
10
we are
to okay. Somebody say 11, we are good. I might even sleep. Oh, it will shock you that I'm sleepy and pitchy. All right, so no problem. So I
What's the
think
boot camp about? What's the boot camp about? And can we
okay.
also attend?
Yes, if you've registered before, you can attend. And I don't know whether the registration is still open. They pasted it on Fitech China. Yeah, the blockchain, Web3 blockchain. Yeah. So it's basically Lightning. Lightning is like a layer two for Bitcoin for payment. So they are running a 4 days boot camp, Wednesday, which is tomorrow, Thursday, Friday, Saturday, and it's from 10 a.m. to 3, right? To 4 p.m. at Nexus. You should know Nexus now, Tally.
Yeah, I do.
Yeah, so that's where they are holding it. So you can check the link. I don't know if it's still open. You can check register.
For our own level like this, for this level that we are in the Web3 space, can we
Yes.
also attend?
And so, one thing with knowledge is that knowledge is not absolute. Knowledge is progressive. So something like programming now, somebody can learn A, B, C, D, E, F before getting to Z. Another person can learn A, B and jump to P, O, P, Q, R, S and jump to X, Y, Z and then come back when he needs the order. So, tech is not, so that's just how it is. So if you attend, I know that you still gain one or two things. And the material, definitely. I will download it now and send to
Akanimo, wetin be your problem? Eh?
Very important.
Very, very important.
Adeba, can you na senior dev? Oh.
I
You na
tell you,
senior
senior
dev.
dev.
Me, I
Wala,
no be senior
wala,
dev.
I go use police carry you. Mind yourself. Oh.
Are they backing where they tutor other people?
Hey. So I will download the material now and then send it to the technical. I don't know who is the mentor in charge of this session. Okay, Yunus. So I'll send it to Yunus to send to the Discord channel. Yes. So it's all nice seeing all of you. We'll meet, I think, next
Thank
tomorrow,
you,
right?
sir.
Yeah, you're
Thank you,
welcome.
sir. Yes.
You're welcome.
God bless you. It's only God that will repay you. Give you all you
Amen.
want.
Amen.
Like
Amen.
100M like this in your account.
Amen. In US dollar,
In dollars, in dollars.
Yes,
correct,
yes. Of course.
correct. All right. Oh, you guys
Probably
should
sir
have.
already has 100M in naira, so it's remaining in dollars.
No, nah, no, nah. All right. So you You guys should have a great nice day. And if
See as
possible,
Christiana they laugh. Christiana we know they laugh
Oh,
before. She say as they laugh. Aye.
I dey laugh now. Aba. I dey
You
laugh.
Christiana
feel
no go
laugh like
stop
this
our
last week.
star.
You will
Make
not
us
feel
dey
laugh.
continue.
Mr. Gideon, may I tell you something? Like that last week, if I join the class like this, I will just sit everywhere, just be silent. I go see what happen. How all of them know they talk? Hey, oh
We
boy, they
dey
know they
mourn.
talk. Now only I do see they talk small,
We dey
small.
mourn Ross. Ross was dying last week.
And that time, this girl, Christiana, going to complain about low battery, low battery. Today, she not complain about low battery.
no complain about
Ah,
no
no. Yeah,
it is well, oh, it is well.
I beg, who don't understand this? Waiting they call that delegate contract. You know what? Waiting with that system. Upgradable contract. Who don't understand that? I beg, who understand that?
Me I never understand
I
normal
just leave that
contract.
one
I
one
can't
side though.
delegate am.
So,
Me, I don't even know wetin be upgradable
I
contract.
don't write that thing. I don't tire. I go write her like this. Now I go see crazy error. I don't do am like maybe 20 times.
I
Sef.
no
I don't
I no
tire.
stress myself. I wan understand the contract first before I come dey
I don't
delegate
leave
am.
now.
Oh boy, that delegate na another level on im own. E just good say we know say they fit delegate contract at least.
Omo, I happy today. I no go lie. Abeg, una leave
Christy, this
upgradable
one
contract now.
we thank God say we throughout last week you know dey dey class.
Allah no come. Wetin be the use?
Omo, and our time hot that last week na so evening.
Omo, that class last week, the thing dey give me headache. I no understand at all. I confused. So there's no even need
Omo,
for me.
Mom said, I don't even
na
take to know how to take start. Sef.
na documentation she dey take teach us na straight up.
I dey even vex now why I use my data go rewatch those videos sef. I dey vex like this.
I never even watched that.
Yeah, I watch all I watch all during the weekend.
Anything wey make
Uh,
me don miss class, I no dey go back go watch any video.
I never watch anything. I no watch that one at all.
Omo guys, na take care. Me, I go sleep. Make I calm my head down for us.
Omo Tani,
Honest.
I wan be like you. Oh boy.
Na senior dev now.
Oh boy.
I beg.
Na bye bye.
Okay now, bye everyone.